So more word problems with rectangles and squares and such. So you've got Kevin. He has a 5 feet by 7 feet picture. That's a huge picture. And he wants to center it on a wall that has an area of 80 square feet. He wants to have the picture placed in the center of the wall so that the border of the picture must be the same width all around the picture. We want to find the length of the border. So if he has a wall, I'm going to draw a picture of the wall. What are the dimensions of this wall? 5 by 7. So I'll make the 7 feet the bigger side. I'll make the 5 feet the smaller side. It does not matter who you want to declare as the length and who you want to declare as the width. Now wait a minute, that's not right. He has a 5'7" picture. So this isn't 5 feet by 7 feet. We don't know how big the wall is. What do we know about the wall though? It has an area of 80 feet squared. So hold that. That one's off. So we do know we have an area of 80 feet squared. All right. But we have a picture that's 5 by 7 that's going to go in the center of the wall. So here's my picture. Seven feet, 5 feet. That makes more sense. Now this one is different than the other ones we've done because the other ones we've added a little bit of length on one direction versus the other direction. Here we're adding on a length all the way around the picture. So I have some distance that goes from here to here. We don't know what it is. What are we going to call it? X. Well, I don't know what it is from here to here, but isn't it the same as this side? Yep. So now let's use some common sense and logic here. We know from here to here is x feet long. From here to here is 7 feet long. From here to here is x feet long. So how long is it across the whole distance? Well, 7 from here to here. Well, x plus 7 would be from here to here. 2x plus 7. So x plus 7 plus x. X and x are like terms, so we get 2x plus 7. Now on that same idea, not only do we have x feet added on this side and x feet on this side, how wide is it from here to here? It's x, because we have the same width all the way around. And then from here to here is also x. Well, from here to here is x. From here to here is 5 feet. From here to here is x. How much is it from top to bottom? 2x plus 5. So with these word problems, really the idea is being able to understand how to set up the picture and to label the picture. Because once we have the picture and we have it labeled, I hope we can go right to our formula and we can start substituting. I'm going to get rid of the a, and what are you going to put in its place? 80, because you know all of this is 80 feet. I'm going to get rid of L. Who do you want to be the length? Sure, 2x plus 7. And then get rid of the w, we'll put in the width, which is 2x plus 5. And here's where I'm going to start you, but then let you go ahead and finish that part while I come around and check your homework. Before we can finish this problem and set it equal to 0 and all that kind of good stuff, what do we have to do with this? Distribute. All right. I'm going to set you to task here. You're going to use the distributive property and distribute. Combine like terms, get 80 to the other side, and then you're going to employ your factoring rules to see what you can do. Pause that. All right, once we were here, we have 80 equals 4x squared plus 10x. That's that first one. That gets me 14x plus 35. And then I've got 80 equals 4x squared plus 24x plus 35. Our rule with factoring, though, is in order solving quadratics with factoring is in order to be able to do that, what better be on one-sided equal sign? A 0. So what are we going to do? We're going to subtract 80. Now, 4x squared and 24x are not like 80. So I'm going to put them over with the like term that he's like. That's going to give me my 0, 4x squared, 24x, and then we get 35 minus 80 gives us negative 45. Yes? All right. So once we are there, now you are ready to solve by factoring. So your part is to determine whether this is a long trinomial, short trinomial, a difference of squares, or a GCF problem. Which one is it? Long trinomial. So a trinomial, we do the x. What goes on the top of the x? You've already done it. 140. Try again. Negative 180. To get that number, you multiply your leading coefficient times your constant. Watch the sign. What goes on the bottom? Positive 24. So you're looking for two numbers that multiply together to give you negative 180, but they add up to give you a positive 24. Make sure you put your negative 180 in your y equals screen. Since you are looking for a negative to multiply, you're going to get two terms that have different signs. But I'm looking for the pair that are going to add up to give me a positive 24. No, we like 6. Ooh. Yeah, 6 and negative 30 will get me negative 24, which means negative 6 and positive 30 will get me what I need. So you can look in either values. Again, if you find yourself getting a pair that gives you the opposite, just switch the signs. Since this is a long trinomial, this becomes 4x squared minus 6x plus 30x minus 45. You can use backwards box or you can use grouping. I'm going to go backwards box for those that are still working on the factoring skills. 4x squared goes in my top left. Negative 45 goes in my bottom right. All right, so let's factor. Greatest common factor of this column is? Ladies and gents, I think we should all be able to figure out what goes into 4 and 30. A 2. And what else? And an x. This column? I don't care if there's dead silence on the recording. What will go into both 6 and 45? If we're not sure, I should hear the sweet tapping on the calculator because you're deciding, the factors of 6 are 1, 6, 3, and 2. We're going to pick a number from that list and find the largest one that divides into both 6 and 45, which is, does 6 go into 45? Oh, it's right there. 3. Positive or negative? Negative. That's how we figure out a GCF, ladies and gents. Find your factors of your smallest number, make that list if you're not sure, and then find the biggest number from that list that will go into both terms. Then we find our greatest common factor of this row, 2x. And this row, so I've got 2x minus 3. 2x plus 15. Yes, there's an equal 0. That hasn't gone away because your goal is to solve these quadratics, not to factor the quadratics, to solve. To solve means you need to tell me what x is equal to. What do I do with each one of these factors now? Thank you. Zero product property from the last 2 days tells us that once it is factored and equal to 0, we can take each factor and set it equal to 0. The rest of this should be just from 8th grade math, if not 7th grade math. I'm going to add 3, and then I'm going to divide by 2, which is going to give me 1.5. And then I'm going to subtract 15, and then divide by 2. And one of these answers doesn't make any sense in the context of this problem because we're talking about feet in terms of a wall. Which one doesn't make sense? Okay, so it looks like it has 1.5 feet on each side. So we're going to see if that makes sense. If I put 1.5 feet here and 1.5 feet here, that gives me 10 feet total. If I put 1.5 feet here and 1.5 feet here, it gives me 3 and 5, which is 8. And does my 8 feet times 10 feet get me an 80-foot squared wall? Yes, it does. So find the length of the border. Well, the border, we would say, to answer the question, the border is 1.5 feet all the way around. And that should take care of your notes.